Assalamualaikum. My name is Mohd Fakrurrazi bin Azri from Group 27. Our group will present project digital electronic. It is our group member. First, Mohd Faiz Farhan bin Mohd Farizal, Mohd Fitri Hakimi bin Mohd Zaharizan, and Mohd Iqbal Hakim bin Mohd Nizam. I will present introduction for this project. Number 1, flip-flop. Flip-flop is an electronic circuit which two cable state can be used to store binary data. The stored data can be changed by applying verifying input. Flip-flop and linkage is a fundamental building block of digital electronic system used computer and many other type of system. Number 2, register. A register is a group of flip-flop used to store a binary word. One flip-flop is needed for each bit in the data word, and gate can be used to store or enable data gate into a register. Number 3 is counter. Counter is a sequence circuit. A digital circuit which is used for counting pass is no counter. Counter is the Windows application of flip-flop. It is a group of flip-flop which a clock signal apply. Counter are of two types. Number 1, asynchronous of ripple counter and synchronous counter. Number 4, finite state machine, FSM. A finite state machine, a finite automaton, or simply a state machine is a mathematical computer model. It is an abstract machine that can be in one of a finite number of states at any one time. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Farhan bin Farizal. My meeting number is A21002. Now we present about the finite state machine, FMS. Okay, now we go to the first step, which is draw and design. We draw and design the state diagram like 720, 021, 124, 425, 522, 223, 326, and repeat the rotation. Okay, next we go to the second step, which is we build the net state table. Okay, in the state table we put two things like output and input. Okay, for input we set the preset state, and in output we put the net state. Okay, in preset state we have three things, QA, QB, QC, and we put the number as usual. And in output net state we insert the answer. Okay, next we build the excitation table. Okay, we put the answer at net state table in this table, and we add the flip-flop C, flip-flop B, flip-flop A. Lastly, we build the KMAC for flip-flop C, flip-flop B, and flip-flop A. That's it. Okay, now we go to the simulation and result. Okay, as you all can see, this circuit simulation that our group make for answer. Okay, for answer the question A. Okay, question A. Okay, next I will show you all the simulation for our circuit. Okay, let's start now. Okay, as you can see, the light of LED turn off and turn on with the set that our group make for this circuit. Okay, that's all from me. Thank you.
My name is Mohd Iqbal Hakim bin Mohd Nizam. My matric number is AA211832. Today I will present about the simulation of parallel in-shift registers using 7476JK flip-flop. So first we need to power up the circuit. So we need to turn on all the inputs and turn the clear on. The output all of FFA to FFD is 0. Next, we need to clear asynchronous. So we need to turn off the clear. The output is 0000. Next, we need to turn on the parallel load. So we need to turn on the clear and turn off input B. The output is FFB equals to 1, while the other is 0. Next, we need to shift right. So we need to turn back the input B. And then we need to click on the clock. So FFC becomes 1. And then we need to click on the clock again. FFD becomes 1. We need to click on again. FFA becomes 1. And for the line 7, we need to turn on, click on the clock again, FFB equals 1. And then we need to turn again for the line number 7, FFC becomes 1. And for the final, we need to clear, so we need to turn off the clear. This will clear out all the outputs, and then we need to turn back for the parallel load. We need to turn back the clear, and we need to turn off the B and C input. The output is FFB and FFC becomes 1. Next, we need to turn back the input B and C and shift right for line number 11. FFC and FFD becomes 1. Shift right line number 12. FFD and FFA becomes 1. Line 13. FFA and FFB becomes 1. Next, line number 14. We need to click on the clock. FFB and FFC. And the final line, line number 15, we need to click on the clock again. So the output is FFC and FFD becomes 1. All the outputs is stated in the table. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Fitri Hakimi bin Muhammad Zaharizan and my matric number is 88212404. So for continuing our presentation, I will explain to you all about conclusion. So a conclusion, as a result of this project, we have learned how to build more machine with 3 JK flip-flops or for a transition state diagram using our own counting sequence, as well as how to construct the circuit for a shift register with 4 bytes of parallel in load, and we get a result or outcome as we want. Other than that, we have learned how to cooperate as a team and support one another. We can use this pure value in the future, such as when we are not at work, when we are at work. Finally, we hope that all of this information will be incredibly beneficial to us.